So in the last lecture, we have seen how to design a one-way slab, and we know that the one-way slab bends only in one direction. Uh, Now let us consider a design of two-way slab. So design a two-way slab 5 meter by 4 meter subjected to floor finish load of 1.5 kilonewton per meter square and live load of 5 kilonewton per meter square. This is the data given. Are you with me, Tanisha?
Yes, sir.
Yes. Now, I have just shown the pictorial representation of that two-way slab. So for a slab to be two-way, it must be surrounded by beams on all the four sides. That is the basic requirement. If the slab is not surrounded by beams on all four sides, we will not consider it as two-way slab. Are you with me?
Yes, sir.
Okay. And there is one more requirement, and that requirement is Ly by Lx ratio should be less than 2. So Ly is the longer span and Lx is the shorter span. So you can see what is the longer span here. It is longer span is 5 meter and shorter span is 4 meter. Are you with me?
Yes.
So that ratio 5 by 4. Can you tell me how much is that? 5 by 4 is 1.25. Am I right?
1.5. Yes, sir.
Yes. So this is the step number one. The first thing that we do is we check if Ly by Lx ratio is less than 2. Then only it is two-way slab. Uh, Apart from the condition that beams must be present on all the four sides. Are you with me?
Yes, sir.
Therefore, two-way slab. Now, you can see these dotted lines. So what do these dotted lines represent? These dotted lines represents the inner edge of the beam. Are you with me?
Yes, sir.
So let me say if I take the view X, uh, what would I see? So you can see there is a column at the corner. There is a column at the corner. On these two columns, the beam is resting, and uh, on the beam there is a slab. Are you with me?
Yes, sir.
So how does this view look like? So let me draw this view. So you have columns here. On top of the column, you will have a resting beam. So this is the beam that rests on the column. Are you with me?
Yes, sir.
And what is the span? The span is this side is 4 meters. So I have to show this as 4 meter. So this is 4 meter. Are you with me?
Yes, sir.
4 meter. So as you view from this side, that means you are taking a cut somewhere here. X, X. So this is view XX. So this beam will not be seen. So therefore, I need not this this beam's bottom edge will be seen. So this is that edge. Are you able to imagine?
Yes, sir.
Okay, and you are going to cut this beam as well. So how does that beam look like? So that beam is going to look something like this. Are you with me? So if I
Yes.
number the beams, let me call this as B1. Let me call this as B2. So when you take a cut like this, you will see this as B1, the cross section of the beam. You will see this as B2. Are you with me?
Yes, sir.
Ulta हुआ, I think. This is B2 and this is B1. You're looking from this side. So first of all, you will see B2, then you will see B1, left to right. Are you with me?
Yes, sir.
And let me call this beam as B3. So this edge is of beam B3. Happy?
Yes, sir.
So you will see the bottom edge of this beam B3 and this slab also will get cut. So let us say slab has some thickness which will be naturally less than the beam's thickness. So that slab will be seen something like this. Are you with me?
Yes, sir.
So this is the slab that you will see. And as the slab portion is cut, that's why I am shading it. So I will call this as slab S1. So this is slab S1. Happy?
Yes, sir.
Now, under the action of loading, this slab is going to bend like this. Do you agree?
Yes, sir.
So this bending occurs, this bending, I have shown it in this fashion. Are you with me?
Yes, sir.
Now let us look at view YY. So how does view YY look like? Let me draw that as well. So this is section YY. I'm giving a cut here, YY. So how does view YY look like? So first of all, you are going to see beam B3, then you are going to see beam B4. Let me call this beam as B4. Happy?
Yes, sir.
Let me also number the columns. This is column C1, this is column C2, this is column C3, and this is column C4. So when you are viewing in X direction as section XX, which columns are you going to see? C3 and C4. Are you with me? So this
Yes,
is
sir.
C3 and C4. These are the columns that you will see. Happy? Now, when you are taking section YY, this is section XX. When you take section YY, which columns will you see? You are going to see column number C3 and C2, isn't it?
Yes, sir.
So let me draw that column C3 and C2. So this is C3 and let us say this is C2. Are you with me?
Yes, sir.
And you are going to see beams B3 and B4. So let me draw those beams. So this is beam B3 and this is beam B4. Are you with me?
Yes, sir.
And you are also going to see uh, the bottom face of beam B1. Are you with me?
Yes, sir.
So that will be seen something like this. This is the bottom face of beam B1. Just a second. Yes. Now, this is the top face. So let me mark. These columns are C3 and C2. Are you with me?
Yes, sir.
C3 and C2. Then the beams which you see are B3 and B4. So let me mark them B3 and B4. Happy? And then you are going to see this bottom edge of beam B1. So that bottom edge is this. This is beam B1. And you are also going to cut this slab S1. So that slab S1 gets cut something like this. And you see slab S1, isn't it? Are you with me?
Yes, sir.
So this is slab S1. How does this slab bend? This slab is going to bend in this fashion, which I have shown here. So you can imagine the entire slab bends like a saucer. The way saucer has curvatures in both the planes. So it bends in one direction and perpendicular to it as well. So something similar to that is going to happen. This slab is going to bend like this as well as like this. Are you with me?
Yes, sir.
Okay. So now the question is, I have to design this slab for bending in two plates. Let me call this as x-axis and let me call this as y-axis. Are you with me?
Yes, sir.
Let me reverse it. Let me call this as X, and let me call this as Y. Are you with me?
Yes, sir.
Ah. So the shorter span, shorter direction, I'm going to call it as X. Longer direction, I'm going to call it as Y. So you can imagine that this slab is going to bend in XZ plane as well as in YZ plane. Are you with me?
Yes, sir.
And I have to design this slab for bending about both the planes. So how do I do that? So for that I need to calculate the bending moments, isn't it?
Yes, sir.
But before that I need to calculate the thickness of the slab. So the step 2 here, this was step 1. So let me mark that step 1. In step 1, what did we do? We checked that whether the slab is one way or two way. So Ly by Lx is greater than less than 2, and the slab is surrounded on all sides by the beams, therefore it is two-way slab. What is the step number 2? Are you with me?
Yes, sir.
So in step number 2, we are going to calculate the depth of the slab. Depth of slab. Are you with me?
Yes, sir.
So how do we calculate this depth of slab? So I have already told you that depth of slab depends on the L by D ratio. So we need to know what is the boundary condition of this slab. Are you with me?
Yes, sir.
So let me show you what do I mean. Boundary conditions of slab. Two-way slab. Ah, So let us consider. Do we have a plan here? Let me consider the floor plan. With slab smart. Hmm. So consider this floor plan. Are you able to see the floor plan?
Yes, sir.
Ah. Now forget about what these lines are marked here, but let us consider this slab. Are you able to see my arrow?
Yes, sir.
हाँ, तो ये स्लैब अगर आप देखते हो तो इसके इस साइड में कुछ है, कुछ नहीं है. Are you with me?
Yes, sir.
On this side, however, there is another slab. Do you agree with me?
Sir.
On this side, there is another slab. Do you agree with me?
Yes, sir.
On this side, there is nothing because it is duct. ये cross का mark है मतलब it is a duct. Are you with me?
Yes, sir.
So there is nothing on this side and there is nothing on this side. So what is the boundary condition of this slab? तो हमें इस slab का boundary condition कैसे देखना है? So देखो, we have to say that the boundary condition of this slab is two adjacent edges discontinuous. क्या बोलेंगे? Two adjacent edges discontinuous. Other two edges are continuous because there is a slab on the other side. Are you with me?
Yes, sir.
So let us do few exercises. Let me consider this slab. Are you able to see this slab?
Yes, sir.
तो अब इसके left hand side में is there a slab? Yes. On the this side is there a slab? Yes. Is there a slab on this side? Yes. Is there a slab on this side? Can you tell me?
No.
No. So therefore this slab has its three edges continuous. Do you agree with me?
Yes, sir.
हाँ, लेकिन सिर्फ थ्री एजेस कंटिन्यूअस बोल के नहीं चलेगा, हमें ये बताना पड़ेगा कि कौन सा एज डिसकंटिन्यूअस है. Is it the long edge, one long edge which is discontinuous, or one short edge which is discontinuous? So you can see this dimension is greater than this dimension. So let us say this is the longer edge. So we will say one long edge discontinuous. and other three edges continuous. This is the boundary condition. Are you with me?
Yes, sir.
Okay. Uh, Now can you look at uh, this slab? Hmm. तो इसके लेफ्ट हैंड साइड में स्लैब है? यस. डू यू एग्री?
Yes, sir.
इसके राइट हैंड साइड में स्लैब है कि नहीं है?
Yes, sir.
हाँ. इसके below, is there a slab here?
Yes, sir.
On upper side, does it have a slab?
Yes, sir.
So इसका बाउंड्री कंडीशन क्या होगा? All the four edges continuous. Are you with me?
Yes, sir.
Okay. So now if there is no such boundary condition given in the problem, we will make an assumption that this is the slab with all edges discontinuous. Are you with me?
Yes, sir.
All edges discontinuous. हाँ, तो assume all edges discontinuous का मतलब होता है you are going to consider the slab as simply supported. That is, slab is considered as simply supported in both directions. Both directions. Are you with me?
Yes, sir.
So while bending in both the directions, we will consider this slab to be simply supported. Or assume all edges are discontinuous. इसका मतलब वो है. So for simply supported beam, does IS 456 give you the limiting value of L by D ratio? Yes, we have seen. What is that value? 20. Do you remember that?
Yes, sir.
Now question is which L should we consider here? So we consider here the shorter value, that is shorter span. Lx की value यहाँ पे हम consider करते हैं. Are you with me?
Yes, sir.
So here we are going to substitute Lx by D equal allowable Lx by D divided by D must be equal to 20. This gives you what is the requirement on D? What should be the value of D? Tell me. How much is D required?
200.
Can you tell me?
Sir, it is 200.
So D required is equal to 200 mm. So we will provide D equal to 200 mm. Now let me draw the cross section of this slab. So if I draw the in this direction like this, and you are going to have reinforcement in this direction as well. Tanisha, am I audible now?
Yes, sir.
Okay. So we have bars in both the directions for a slab. So we have calculated the value of D. That D can be shown on this diagram like this. That D value is 200 mm. Are you with me?
Sir.
So it is up to the center of this bottom bar. Happy?
Sir.
Okay. So now, how do I calculate capital D value? to calculate the capital D value, I will require to add half the bar diameter in this. Happy?
Sir.
So I will assume the bar diameter to be 12 mm. So half of 12 needs to be added to D, and I need to add clear cover. Clear cover is this distance. Are you with me?
Sir.
And how much is that distance? That distance we take it as 25 mm. So this is plus 25 mm. So can you tell me what is this sum? 200 plus 6 plus 25. कितना आ रहा है?
It is 231.
So we cannot provide 231. So nearest 10 mm के multiples में nearest को round off किया तो we are going to provide 240 mm. Happy? Capital D will be 240 mm. In last case also it should have been 240, but we have taken 1.5 times diameter. वो गड़बड़ थी, ये इतना ही लेना है. So 240 mm last case में भी depth होना चाहिए, ना कि 250. Are you with me?
Yes, sir.
But even if you provide 250, that's all right, because this slab is going to be safe. You are going to provide 10 mm extra. It's all right. So we will not revise the previous design. We will keep it as it is. Happy?
Yes.
So here we are going to provide capital D equal to 240 mm. So let me show that capital D. So this thick slab thickness is 240 mm. Happy?
Yes, sir.
Now let us do the next step, and that is step number 3. Step 3. What is step 3? Load calculation. Are you with me?
Yes, sir.
And for load calculation, what do? We consider a chunk of 1 meter by 1 meter on the slab. So this is 1 meter and this is also 1 meter. Happy?
Yes, sir.
So 1 meter by 1 meter chunk के लिए हम लोड कैलकुलेट करते हैं. तो let us calculate UDL due to self weight of slab. So let me calculate that. So how do I calculate that? I have to compute the volume of that 1 meter by 1 meter chunk. So it is 1 meter into 1 meter into 0.25, which is the overall depth of 0.24, which is overall depth of the slab in meter, multiplied by density in 25 kilonewton per meter cube. Are you with me?
Yes, sir.
So this turns out to be how much? Tell me how much it is. 0.24 into 25.
Sir, it is
Pardon? Hello?
6. 6, sir.
So 6 kilonewton per meter square, because it is the load acting on 1 meter by 1 meter chunk. So here we will consider it as 6 kilonewton per meter square. In last time we were considering it as a UDL on beam. So there we consider it as 6 kilonewton per meter. But here we will consider it as 6 kilonewton per meter square. Are you with me?
Yes, sir.
Okay. Now second. Chalo. Floor finish. So what is the floor finish load? It is 1.5 kilonewton per meter square. This into 1 meter into 1 meter. So how much is that? That will remain equal to 1.5 kilonewton per meter square. Though unit wise it is kilonewton per meter square into meter square, it should be kilonewton, but we know this load repeats itself on every 1 meter by 1 meter chunk on this slab. Are you with me?
Yes, sir.
So therefore it is 1.5 kilonewton per meter square. What is the third load? It is imposed load or live load. So how much is imposed load? It is 5 kilonewton per meter square multiplied by 1 meter multiplied by 1 meter, which is equal to 5 kilonewton per meter square. Are you with me?
Yes, sir.
So now what is the total load? Total load, total unfactored factored load. So how much is total unfactored load? Tell me. It is 6 plus 1.5 plus 5. So how much is that? 13.5?
12. Sir, it is 12.5.
12.5. 12.5 kilonewton per meter square. Mind you, this we were considering it as kilonewton per meter in last problem because we were then applying it as a UDL on the entire 1 meter wide a strip of length Lx. Are you with me? But here
Yes, sir.
we are only calculating it over 1 meter by 1 meter chunk. Uh, and the further load calculation for two-way slab is slightly different than one-way slab. So I have written the unit as 12.5 kilonewton over per meter square portion of the slab. Are you with me?
Yes, sir.
Now let us consider factored load. We will denote it by notation WU. And what is that factored load? 12.5 multiplied by partial safety factor for load, which is 1.5. That turns out to be how much? Tell me.
Sir, it is 18.75.
How much?
18.75.
18.75 kilonewtons per meter square. So this slab is loaded by a pressure which is equal to 18.75 kilonewton per meter square. Are you with me?
Yes, sir.
On its entire surface. And this slab is going to bend in two directions. It is going to bend along X as well as along Y. So what will be the maximum bending moment in X direction? What will be the maximum bending moment in Y direction? Both these moments, maximas, are going to occur at the center of respective spans. So if you look at the centroid of this slab, somewhere here, this is the point where you are going to have maximas of both bending moments, moment in X direction and moment in Y direction. But the question is how much how much is its magnitude? Are you with me?
Yes, sir.
So here IS code gives you a table by using which you can directly determine the moments in X and Y direction. Unlike in one-way slab, we calculated it as WL square by 8 for simply supported slab. Do you remember that?
Yes, sir.
But here we have to use directly the coefficients. So let us look at those coefficients. I think it is on page number 52. Let me check. This is IS 456. Are you able to hear me?
Yes, sir.
Okay. Just give me a second. Let me download it so that I can scroll it very faster.
Yes, sir.
First, let me resume the recording. So we are referring to table number 26 of IS 456. It is on page number 91. In the second column, you have been given various age conditions. Our age condition is all the four ages discontinuous. So we will be referring to the ninth row. Column number 3 to column number 2 gives you the values of Ly by Lx ratio from 1 to 2. So Ly by Lx greater than 1 and up to 2, this is two-way slab. Ly by Lx greater than 2 will be one-way slab. So the ratios are 1 to 2. And depending on our Ly by Lx ratio, we will be getting the first short span coefficient, that is alpha x, and long span coefficient alpha y is listed in column number 11. So refer to the ninth row. Our Ly by Lx ratio is 1.25, which is exactly midway between column number 5 and column number 6. So short span coefficient alpha x is 0.072 and 0.079. Midway between them is 0.0755. So therefore alpha x is 0.0755. Are you with me?
Yes, sir.
And now let us compute alpha y. Alpha y is long span coefficient. It is given in the last column. And for ninth row, it is 0.056. Are you with me?
Yes, sir.
0.056. So when the slab bends in shorter direction, we have one coefficient alpha x. When the slab bends in longer direction, we have another coefficient alpha y. And from these coefficients, we will be calculating two moments, MUDX, that is ultimate design moment in x direction, that is short span direction, and MUDY. Are you with me? That is ultimate design moment in y direction. Happy?
Yes, sir.
So how to calculate that? So again, the formula is given in IS code. So let me go to page number 91. I don't know why it is taking time, but it is taking time to load. Anyway, let me go to page number 91, 88. So this is the table that we were referring to. Are you with me?
Yes, sir.
And देखो, how do we calculate MX? MX in our case is MUXD. And My in our case is MUYD. Design moment in X direction, design moment in Y direction. Both the moments are ultimate moments. Are you with me?
Yes, sir.
So how do we calculate that? Alpha X into W. W के जगह हमें substitute करना पड़ेगा WU. Happy?
Yes, sir.
Into LX square and alpha Y WU into LX square. दोनों में LX square ही है. आपको ये समझना है. There is no Ly here. Lx square itself. So let me write down this equation. It is equal to alpha x. देखो, multiplied by WU multiplied by Lx square. Happy?
Yes, sir.
And this is alpha y multiplied by WU into Lx square itself, not Ly square. Happy?
Yes, sir.
हाँ, तो हमें दो मोमेंट्स मिल जाएंगे, कौन से? एक अलोंग शॉर्टर डायरेक्शन और दूसरा अलोंग लॉन्गर डायरेक्शन. जो स्टिल हमें शॉर्टर डायरेक्शन के मोमेंट के लिए मिलेगा, दैट वी आर गोइंग टू प्रोवाइड अलोंग 4 मीटर रन. जो स्टिल हमें लॉन्गर डायरेक्शन के लिए मिलेगा, दैट वी आर गोइंग टू प्रोवाइड अलोंग लॉन्गर डायरेक्शन, दैट इज अलोंग वाई. आर यू विथ मी?
Yes, sir.
And both the steels will be provided at the bottom in this case, because both the moments are sagging. As the slab is simply supported, the slab is going to only sag. So both the steels will be provided at the bottom face. Are you with me?
Yes, sir.
So let us calculate this moment. So how much is alpha x? 0. 0. Tell me. 0. 0.0755. This is alpha x. Happy?
Yes, sir.
Then can you tell me what is the value of WU? Have we calculated WU? Yes. WU is 18.75. Happy?
Yes, sir.
And what is the value of LX square? So LX is how much? Shorter span is 4 meter. So LX square will be 4 meters, 4 square. Are you with me?
Yes, sir.
Now, coefficient doesn't have any unit. 18.75 is in the unit kilonewton per meter square multiplied by a meter square. तो ये मोमेंट किस में आएगा? This will be in kilonewton meter. Are you with me?
Yes, sir.
So tell me how much is the moment. Do the multiplication. Tell me the moment.
Sir, it is 20.65.
20.65.
22.65.
20 22.65 kilonewton meter. And what is MUY? So for उसके लिए हमें क्या करना पड़ेगा? Alpha y. How much is alpha y? 0.056 multiplied by WU, that is 18.75 multiplied by LY square. LX square. LX square कितना है? यहाँ भी LX square ही करना है. तो वो है 4 square. So can you tell me how much is this?
It is 16.8.
16.8 kilonewton meter. Happy?
Yes, sir.
And now let us calculate shear force VU dx. So shear force while bending in x direction and VU dy will be shear force while bending in y direction. So let us calculate those two. So how do we calculate that? So do we have that WU, isn't it?
Yes, sir.
This WU, just give me a second. WU multiplied by LX by 2. This is VU dx. And what is VU dy? That will be WU multiplied by LY by 2. So substitute the values and tell me how much it is. WU कितना है? 18.75 into LX कितना है? 4. This divided by 2 is equal to, tell me how much is that? And tell me how much is this?
Sir, VUDX is 37.5.
37.5 kilonewton. And tell me how much is this?
It is 46.875.
46 point
875.
kilonewton. So we will take a numerically greater value, that is 46.875. Are you with me?
Yes, sir.
So now we know we have to find out reinforcement in x direction by using this moment, reinforcement in y direction using this moment. But before that, let me calculate what is AST minimum. So as per IS code, what is AST minimum? AST minimum is 0.12% of gross cross section. So 0.12 by 100, this entire thing multiplied by this we have done earlier. So I am not repeating, I am not explaining it, into 1000 into 240 gross cross section. So tell me how much is this?
Sir, it is 288.
2
88.
mm square. Are you with me? So this is
Yes,
AST. Now let us calculate AST in x direction. So to calculate AST in x direction, first of all, I will have to prove that this slab is under reinforced. So how do I prove that? So Now I will have to make a choice of material. So let me say I choose M20 and Fe 500. Are you with me?
Yes, sir.
If I make that choice, what is the value of neutral axis factor for balance section? RUB 2.66. We have done this in the last class. Are you with me?
Yes, sir.
So what is the moment of resistance of balance section? MUB is equal to 2.66 multiplied by B, that is 1000, into D square. How much is D? 200. Effective depth 200 square. So can you tell me how much is this value? 2.66 into 1000 into 200 square.
Sir, it is 106.4 into 10 raised to 6.
How much?
106.4 into 10 raised to 6.
106.4 into
10 raised to
10
6.
power 6 Newton mm. Are you with me?
Yes, sir.
So in kilonewton meter, it will be 106.4 kilonewton meter. Are you with me?
Yes, sir.
So now is mu dx and mu dy both less than this value? Yes. So are we going to require still less than what is required for balance section? Yes. So is it under reinforced section? Yes. So bending कौन से भी direction का consider करो, this is going to become a under reinforced section. Are you with me?
Yes, sir.
So mu dx is less than mub, or mu dx, and mu dx is less than mu dy is less than mub. Therefore दोनों के हिसाब से for bending in both directions it is under reinforced section. Are you with me?
Yes, sir.
So when once it is under reinforced section for in both directions, I can find out steel using the formula for under reinforced section. And what is that formula? 0.5. Let me write down that 0.5 FCK upon Fy into bracket 1 minus square root of 1 minus 4.6 mu in Newton mm divided by FCK BD square, and outside this you are going to have BD, isn't it?
Yes, sir.
So substitute now value FCK, as we are choosing M20, therefore FCK is 20. As we are choosing FE 500, therefore FY is 500. Happy?
Yes, sir.
When you are calculating the steel for X direction, MU is 22.65. 22.65, but that is in kilonewton meter. So this multiplied by 10 power 6, that will be in Newton mm. What is the value of FCK? 20. What is the value of B? 1000. What is the value of D? 200 square. This is 1000. This is 200. So can you solve and tell me what is this value? ASTX. I will also
Yes, sir.
solve with you. 0.5 into FCK upon Fy into square root of 1 minus, into bracket 1 minus square root of into bracket 4.6 into 22.65 into 10 power 6. है ना? This
Sir,
divided by
eight
divided
point
by 1000. How much?
268.94.
Okay, let me cross verify. Into 1000 into 100. हाँ, how much did you get?
268.94.
So let me write, that's correct. 268.94 mm square. Happy?
Yes, sir.
But what is the minimum steel? 288 mm square. So which one are you going to provide? 288, isn't it?
Yes, sir.
This is less than AST minimum. So we cannot provide steel less than AST minimum. So we have to provide AST minimum. So therefore provide AST minimum. Are you with me?
Yes, sir.
Now अगर 22 को ही स्टील लेस देन AST मिनिमम आ रहा है तो 16 को जो MUDY है उसको भी लेस देन मिनिमम ही आएगा. Are you with me?
Yes, sir.
So therefore in both directions we are going to provide minimum steel. Logic समझ में आया?
Yes, sir.
अगर ग्रेटर मोमेंट के लिए ही स्टील मिनिमम से कम आ रहा है तो उससे कम मोमेंट के लिए उससे भी कम आएगा, लेकिन हमें प्रोवाइड तो AST मिनिमम करना है. Are you with me?
Yes, sir.
So therefore in both directions we are going to provide steel is equal to 288 mm square. And what is that percentage? That percentage is 0.12 because AST minimum हमने कैसे calculate किया? It is 0.12% of gross cross section, isn't it?
Yes, sir.
Okay. So therefore provide 288 mm square. Up. How do we compute the spacing? So let us consider that I am going to use 10 mm dia bars, or let us consider that I am going to use 8 mm dia bars. 8 mm 5 bars. These are to be used. Are you with me?
Yes, sir.
So how do you compute the spacing? तो spacing मैंने आपको बताया था. This is one bar. Let us say this is second bar. Let us say this is third bar and fourth bar. Let us say we are providing 4 bars in 1000 mm. Are you with me?
Yes, sir.
तो ये so how do we compute spacing? S कितने कितने स्पेसिंग हुए, जितने बार हम प्रोवाइड कर रहे हैं उससे कम एक स्पेसिंग होता है, isn't it?
Yes, sir.
So let us say this is 1000, है ना? तो 1000 mm में अगर हम ऐसे 4 बार प्रोवाइड करते हैं तो व्हाट इज द एरिया ऑफ स्टील? टेल मी. AST कितना होता है बताओ, अगर हम 4 बार प्रोवाइड कर रहे हैं तो AST होता है, बोलो कितना होता है? लास्ट टाइम हमने फॉर्मूला डिराइव किया था ना. कैन यू रेफर टू दैट फॉर्मूला एंड टेल मी हाउ मच इट इज? Anyway, let me calculate the number of bars. Number of bars. I must provide. नहीं, फिर से डिराइव करके दिखाता हूँ आपको, शायद भूल गए आप. Are you with me?
Yes, sir.
So what is the relationship between AST and spacing? This is what we are trying to establish. So let us say this is let us say I am providing 5 bars. कितने बार्स प्रोवाइड किए हमने? 5 बार्स. कितने width में? 1000 mm width में. Do we have to provide this AST in 1000 mm width? This 288? Yes. Are you with me?
Yes, sir.
So 1000 mm में अगर हमने 5 5 बार प्रोवाइड किए तो स्पेसिंग कितने होते हैं? 1, 2, 3 और 4. So if you are going to provide n number of bars, there will be n minus 1 spacings. Do you agree with me?
Yes, sir.
And how much is the AST that you are providing? Tell me. So AST will be 1000 by S. तो यहाँ स्पेसिंग कितने हुए? देखो 1,
Sir, you are not audible.
Shreya, am I audible?
Yes, sir.
Okay. So if I provide 5 bars here, I get 4 spacings, 1, 2, 3, 4. So 1000 divided by S. हाँ, तो ये कितना, ये नंबर यहाँ पे कितना होगा? 4. 1, 2, 3, 4. Are you with me?
Yes, sir.
Now, what is the AST when I am providing 5 bars? The half bar goes on the other 1000 mm. This half bar goes on the other 1000 mm. So ये आधा और ये आधा पकड़ के एक और बीच के 3 ऐसे 4 बार होते हैं. Are you with me? So this 4 represents the number of bars that are accommodated in 1000 mm. This multiplied by area of 1 bar, that is pi by 4 into pi square. So what is the relationship between AST and spacing? Area of steel required must be equal to 1000 divided by S into area of 1 bar, pi by 4 into 5 square. What is the phi that we have chosen? 8 square. So from this, can you tell me what is S? Because we know that AST needs to be 288 mm square minimum. Are you with me?
Yes, sir.
So can you tell me what is the value of S? It's 288 upon 1000 upon pi by 4 into 8 square. 288 upon 1000 divided by pi by 4 into 8 square. कितना आ रहा है?
Sir, just a minute. Sir, I'm getting it 14.47.
No, it is 174.53. Check करो. देखो, if I simplify this, S is equal to 1000 divided by 288 into pi by 4 into 8 square is 50. देखो,
Sir, I'm
how much
getting
is
it as 17.453.
No, 17.453 is wrong. 174. देखो ना, 1000 divided by 288 into 50.
Sir, I got it
Once,
as 174.53.
you got it. No? So it is 174.53 mm. So we need to provide spacing equal to 174.53. Now we cannot provide this spacing on this side. So it has to be rounded off in multiples of 10, but on lower side, because when you reduce the spacing, you will increase the steel. Are you with me?
Yes, sir.
So therefore we will provide 8 mm phi at kitna spacing? 170 mm spacing, 170 mm spacing, center to center in both directions, in X and Y. X and Y, both directions. Are you with me?
Yes, sir.
And where? At bottom. So in bracket B. So how does the plan, reinforcement plan look like? So this is the slab. Are you with me?
Yes, sir.
And we are going to provide bars like this. and bars like this, one over the other. These bars run up to end to end. Though I have shown it as a cut line, they go up to the end. And what is the description of these bars? We are going to provide 8 mm phi at 170 mm center to center in X and Y both directions at the bottom face. Are you with me?
Yes, sir.
Okay. Now there remains the last check, after which we will stop for the day. So step 4, last check. What is the check? That is shear check. Are you with me?
Yes, sir.
So for shear check, first we need to calculate what is the value of tau shear stress at ultimate design load. Tau tau V U D. V stands for shear, U stands for ultimate, D stands for design. Happy?
Yes, sir.
Now we have two shear forces. कौन से shear forces है जरा बताओ, हमने calculate किए थे. One is VUDX and VUDY. We will consider greater of the two. If the slab is safe for greater of the two, it is naturally safe for the other one, isn't it?
Yes, sir.
So what is greater of the two? 46.875 kilonewton. Happy?
Yes, sir.
So I will take that 46.875 into 10 power 3. This is the force in Newton. And what is the area of the slab? 1000 mm into 200 mm. This is B and this is D. So can you tell me what is the stress? Point 0.23, isn't it?
Yes, sir.
So this turns out to be 0.23 MPa. So which grade of steel we are using? M20. And what is the percentage of steel that we are providing? So what is 100 AS by BD? Percentage of steel that we are providing. It is minimum steel, so it is 0.12%, isn't it?
Yes, sir.
So अब हम कौन सा table refer करेंगे? We are going to refer two tables, table 9 and table 10. So let me go to table 9 and table 10. That is on page number 72. अरे 56 कैसे आया? These are the tables. Are you able to see the tables?
Yes, sir.
So we are going to refer first to table number 20. So from table number 20 for M20 grade, what is tau C max? That is 2.8. For M20, tau C max is how much? 2.8 MPa. From where did we get this? We got this from table. कौन सा table है? Table number 20. IS 456. Are you with me?
Yes, sir.
So is tau VUD, tau VUD less than tau C max? Is it so? है कि नहीं?
Yes.
Therefore, okay. So we need not revise the depth. That is first check. The second check is we are going to refer table 19 and we are going to find out how much shear stress can the concrete resist with these bottom reinforcement but without any additional shear reinforcement. So what is the AS by BD in our case? Less than 0.15. Happy?
Yes, sir.
0.12 है ना? So and now for M20, what is the value of tau C? 0.28. Are you with me?
Yes, sir.
So tau C is equal to 0.28 MPa. Which table are we referring to? Table 19 of IS 456. Now, is tau VD less than, is tau VD, tau VUD less than tau C?
Yes, sir.
Sorry, yes, it is less than tau C. Therefore, no shear reinforcement is required. No shear reinforcement. ये बीम में लगता है, स्लैब में नहीं लगता. Required. So therefore, shear check is complete. We need not revise the depth, and no additional shear reinforcement is required. Happy?
Yes, sir.
So this completes the design of two-way slab. And in tomorrow's class, we are going to complete the design for short column, and that will be the last lecture. Tomorrow's lecture will be the last lecture. Do you with me?
Yes, sir.
Okay, so let us stop here today. Have a good day.